Good morning everyone, and welcome to the video lecture 5 on the sequencing. So in the previous video we have studied three kinds of problems in this particular chapter, and this is going to be the last particular kind of a problem, which is two jobs and M machines. Okay, two jobs, M machines. So we'll see the first question. Use graphical method to minimize the time in hours needed to process the following jobs on the machines shown. That is, for each machine, find the job which should be done first. Also calculate the total time elapsed to complete both the jobs. Okay, again here we need to find the idle time and the total elapsed time and all. Okay, so whenever the two jobs are given, only two jobs are given, you need to go for a graphical method. Okay, J1, that is job 1, you need to take horizontal line, and job 2 you need to take on the vertical line. Okay, horizontal line indicates J1, vertical line indicates J2. Okay, and one more thing you need to remember, that is when in the operation, if you get a horizontal line, okay, that indicates J1 is in processing and J2 is idle. See, you might have observed that in the PV diagram, okay, in the pressure volume diagram in the BTD, if you get a straight horizontal line, the pressure is constant, volume is changing. Okay, that in the same way here, if say for example in this figure, if you get the straight horizontal line, this means that J2 is idle. Okay, J2 is idle, J1 is processing. The job 1 is somewhere on some machine. Okay, I don't know in which machine it is, but somewhere J1 is in processing. Okay, and vertical line indicates what? In the pressure volume diagram, vertical line indicates volume is constant, pressure is changing. In the same way, here vertical line indicates J2 is under processing, J1 is idle. See, here will be the volume, here will be the pressure, no? The vertical line indicates what? Vertical line indicates this is constant, that is J1 is idle, constant, J2 is in processing. And what if it is an inclined line? Inclined line indicates both jobs are under processing on two different machines. Here there is no necessary that you have to complete first job and then you have to go for second job. No, you can process two jobs on two different machines at a time. Okay, so this is the brief introduction about this particular kind of a problem. Okay, now we'll see how to solve this. See, it is very simple. First you need to draw the graph. So here will be the J1, that is in the horizontal direction, X direction. J2 will be in the Y direction. First you have to note down, see, this is the sequence they have given, A, B, C, D, E sequence, and for job 2 it is B, C, A, D, E sequence. In that way only we need to tabulate in the graph. Okay, let us see. First the job is A, that is 3 hours. So it is in hours. Okay, so 3 hours. So first in the actual scale you need to take 3 centimeter. Here 1 centimeter is nothing but 1 hour. Okay, so 3 hour is nothing but 3 centimeter. So this area is, sorry, this line is about the job A processing time. Processing time of job A. Then go for B, which is 4 hours. No, so here from 3, 1, 2, 3, 4. So up to 7 from 3, it is the processing time of B machine B. Then again go on adding 2 up to 9, it is machine C. Then again add 6. See here, add 6, you will get 15. Then again 15 add 2, you will get 17, that is E. So this is the way to mark A, B, C, D, E machines on the x-axis. Similarly See here, job 2, this is on the right hand, sorry, this is on the vertical direction, y-axis. So here first job is sorry, once again, it is first machine is B. B is 5 hours. So from the origin 1 2 3 4 5, so up to 5 hours it is machine B. Okay, this is machine B. Then add 4, so 5 plus 4 up to 9 hours it is machine C. Up to 9 means from 5 to 9, this is machine C. Okay, then go on adding 9 plus 3 12, that is A. 12 plus 2 14, that is D. 14 plus 6, see, 14 plus 6 20, up to 20 it is F. Okay, this you have marked. Okay, whatever the question, in the question they will be given the sequence. According to the sequence given, you need to mark ABCD here and ABCD here. Okay, now what is the next step? Okay, see here, next step is what? You need to join the two lines to make a rectangles. How to make a rectangle is that, see here, where is A here? On the x-axis it is here, no, it is 3. Okay, draw a straight line from here, not a not a darker line. Okay, just draw a small thin line, and make the two lines here also, that is A is here, no, on y-axis, so it is from 9 to 11, so make two thin lines here also. Okay, where you will get this line also intersection, that you create a rectangle here. It may be a rectangle or it may be a square. Okay, so here it is a rectangle, it is a 2 and 3 here. So this you make a create a rectangle. This is about A machine. Next, B is here, so here draw a two lines, one from 3 and another from it is 7. Yeah, it is 7. Draw a two lines, thinner lines. Okay, and machine B is on the vertical axis is here, no, draw two lines from, one from 0, it is anyway x-axis, and one from here. Where these four lines intersect, no, you will get a rectangle again. So this is about machine B. Clear? Again go on machine C. Draw two lines, one from 7 and one from 9 here, and see this line and this line. Again these four lines will intersect, and that will make actually the rectangle. So this is about C. Okay, next create you know darker lines to show the rectangle C. Then D, again same way, go for D as well as E. Okay, this is the rectangle for E. Okay, and this is the rectangle for D. Up to this one, this is the rectangle for D. Okay, got it? First step is what? You have to mark the given sequence on x-axis and y-axis. Then you have to prepare a rectangles like this by joining. Very simple. I hope this much is understood. So next step is what? You need to draw a 45-degree line. Okay, you need to draw a 45-degree line starting from the origin. Okay, if you are drawing in a graph, simply diagonal, you can say diagonal of this square you need to draw, and up to where you need to draw is up to if you get a machine here, you need to stop the inclined line, then you have to travel along the rectangle. Got it? See, from origin up to machine B, so this is a rectangle, no, this rectangle will stop the traveling of the inclined line. You need to stop here, then you have to go along the rectangle. Again, once there is no stoppage, there is no resistance, again go for a inclined line. See here, this is inclined line. Here also there is no stoppage, there is no stopping. Again go for up to this point, again this end. So once you reach this particular path, okay, not this path, I will tell you this path later. Once you get to this, again there is a restriction here. So go, whenever there is a restriction, go along that particular line. Okay, here. Then again there is a free space, go for inclined line. Okay, then then just along the way, along the rectangle, complete this figure. So at this point, this is the end point, point of finish, you can say. This is the end point. Okay, this is the one possible way, and another possible way was actually here. So here I have gone through the path number 2 now, earlier. Now you can stop here. You can stop here and go straight line, vertical line. Then again there is no restriction. When there is no restriction, always you have to draw a 45-degree line. Again go on, traveling up to this point. Then there is a restriction, because here you cannot able to you cannot able to draw a inclined line, because this is the last point. So just finish the line with the this line, and this is the point of finish. Now you have got two paths. This is the path number 1. Okay, this is the path number 2, whatever it is. So now you need to find the total time. So here, so the total elapsed time to complete job number 1 is processing time of J1 plus idle time of J1. Okay, so from the problem data you can able to find the processing of J1. Simply add them, right? So this just addition, you will get 17 hours. Then idle time of J1 is reached, that is sum of all the vertical lines till the finishing point. So here vertical line indicates what? J1 is in idle. Vertical line indicates J1 is idle. Horizontal line indicates J2 is idle. Okay. So now collect all the vertical lines in the path 1. So here there is a 2 hours. Then here there is a 3 hours. This is 1 hour and this is 2 hours. So there are 3 hours. So from the graph you will get 5 hours. So this is the idle time of J1. Similarly, you find the idle time of J2. So this is the processing time you can find from this addition. Idle time of J2 will be sum of all the horizontal lines in a path 1. That is only here. This is the only horizontal line. So that is 2 hours. So processing time plus idle time will be 22 hours. So this is the total time to complete the job 1 is 22 hours. Job 2 is also 22 hours. In the same way, you have to go for the path 2. So here is a path 2. You just go through the path 2. Here is the processing time. Anyway, processing time is same, no matter whether it is a path 1 or path 2, because it is fixed. That is 17 hours, and processing time of J2 is 20 hours. It is already calculated, right? And idle time of J1, you collect the path number 1 vertical lines. So there will be 8 hours. So total is 17 plus 8 is 25 hours. Okay. And similarly, idle time of J2, collect all the horizontal lines in a path 2. That will be 5 hours. You just refer the figure graph and you will get 25 hours. So now you can say compare the path 1 and path 2. You can notice that path 1 22 hours it is taking. No, it takes less time to complete both jobs than the path 2, which are taking 25 hours each. Earlier path 1 it was taking 22 hours. So now the best possible path is path 1. Okay. Please note that path 1 also has a lesser length than the path 2. Okay. So this will be the sequence of job, and the final solution will be machine A. First you need to process job 1, then job 2. For machine B, you need to first process job 2, then job 1. And similarly, B, C, D, E, you need to process J2 first, then J1. So these are the solutions. Okay. Okay, please note down this condition. Okay. Whatever the LHS is there along the path selected, that is to be loaded first, then loaded second.